All right, so in this video, I'm going to show you how we're going to be able to predict the products of reaction by knowing this piece of information, which is the type of reaction, and using these two charts that are for consult, which are the activity series of metals and the solubility rules for ionic compounds. Now, the types of reaction that we have seen and that we need to keep in mind are 5. The first one, when you have one single product, we call it synthesis or formation reaction or combination reaction. When we have one reactant, we call this a decomposition reaction. And so you can see that in a combination reaction, the prediction is going to be to combine all the elements into the most likely compound that they can make. When it's decomposition, we're going to divide it into either the parts that make it or a very stable compound and a stable element that can be released from the reaction. Then we have the replacement reactions. One is called a single replacement, when one element replaces another in a reaction, and double replacement when two elements replace each other in a reaction. Usually this would have to occur between two elements of the same kind in an ionic compound, like a metal for a metal. And then the last kind is the combustion reaction, where you need to have, in this diagram, A to be a hydrocarbon, oxygen to form carbon dioxide, water, and the release of heat in the form of like light or like a flame. Now, what do we do when we have a set of reactants or possible reactions to work? Like, how do we do the prediction of products? The first thing that we have to do is, like I said, identify what kind of reaction they're going to be. If we look at all the reaction, 1, 2, 3, 4, 5, we can see that number 1 and number 3 are very similar. They both are a combination of a hydrocarbon and oxygen. So in both cases, because there would be combustion, we are going to assume complete combustion and say that the products are going to be carbon dioxide and water because of the combination of the hydrocarbon and oxygen being that the possible reaction. Now then we have, for instance, in problem number 4, one single reactant, which would be the separation of the parts. In this case, silver and oxygen gas, right? Now the last two would be number 2 and 5 are replacement reactions. We can see that in number 2, we have two ionic compounds, iron 3 hydroxide and sodium chloride. And the first thing that we have to know is whether this reaction, and also number 5, potassium bromide and magnesium, are going to take place. See, if the reaction occur, what would be the products of it? To know if the reactions will occur or not, we have to keep in mind something. In the single replacement reaction, we have to know that the element that is on its own has to be more reactive than the element that is replacing. And then in the double replacement reaction, we have to know if one of the combination is going to be either a precipitate or a gas or the formation of water. If none of those occur, then the reaction does not take place. Now, how do we know whether one element is more reactive or if they're going to form either one of the 3 choices in double replacement? We're going to use the tables that I mentioned at the beginning, these two. For number 5, for the single replacement reaction, we would need to know if magnesium is more reactive than potassium. And the activity series of metals tells us this, okay? So here we can see potassium and here we can see magnesium. And the list says that goes from top to bottom, decreasing reactivity. So it's more reactive on the top, less reactive on the bottom. So magnesium is not more reactive than potassium. So in this case, no reaction takes place. If it was backwards, if magnesium is in a compound with bromide, for instance, and would be replaced by potassium, then you would know if the reaction would take place because potassium is on top of magnesium in the activity series, and there would be a reaction where those two would exchange places. But in this particular case of number 5, no reaction takes place. Now, according to the double replacement reaction in number 2, iron and sodium, being the metals, would exchange places, forming iron 3 chloride and sodium hydroxide. Now, how do we know this reaction takes place? This would be the probable products, but that doesn't mean this reaction will occur. First of all, we have to read the rules for solubility of ionic compounds. Now, the rule number 1 says that salts of alkali metals are soluble. This means that there is no precipitate. No precipitate forming means that it doesn't matter what sodium is with, because it's an alkali metal, no solid is going to be formed. Now, then this is not going to be precipitate, so that means it's going to be aqueous, right? So that's not a product that tells us if this reaction occurs. The other choice is the presence of iron and chlorine. So we look in the solubility rules and we find what it says about chlorides. Chloride salts are soluble. Again, soluble means no precipitate. And then there is an exception: silver, lead, and mercury 1. Iron is neither one of those three. So these would also be aqueous. And if both are aqueous, we say no reaction actually takes place. So this is the way that we use our tables to be able to predict products. The first thing, like I said, to be able to predict products would be, first, identify the type of reaction. And second, if a single replacement or double replacement reaction, check if the reaction is viable or not. And that's how you would be able to predict the process.